So for previous notes, we did what if they have the same base, right? Let's pretend that Miss Jones knows how to spell different. And what if they have different bases, right? What do you do? Well, here are the 5 steps that you're going to follow when they have different bases. You're going to write the original equation, and you want to make sure there's only one term on both sides. So it needs to be one term equals one term. Okay, so that's thing number 1. You want to make sure there's only one term on both sides. And then you're going to take the log using base 10. So common log. So we're going to stick to common log of each side. Then you're going to use the power property of logarithms, which is property number 5. And that property is just saying that if I have a log with a power, the power can become the coefficient. Remember that one? Property number 5. Then you're going to use inverse operations to get x by itself. Okay, what this is going to make is our exact answer. So this is going to give us our exact answer. And then we're going to use a calculator to evaluate, and that's going to give us our approximate value. And we're going to practice rounding either to the thousandths, to the thousandths, or the 10,000ths, depending. Okay. So the steps seem like, oh, that's a lot. It's not once you start doing it. And as you get better at it, then you can create your own shortcuts. You can combine steps. But to begin with, we're going to just kind of lay it out as simple as possible, right? All right. So let's dive into when you cannot make the bases the same. So for example, we have 15 to the 2x equals 36. There's no way that I can have 15 and 36 have a common base, right? Because they don't have, they're not repeated powers, well, repeated multiplication. So step 1 is to make sure that there's only one term on each side. Is there only one term on each side? Yes, there is. So we're good to go. Check. Step 2 is you're going to take the log of both sides. So I'm going to take the log of 15 2 to the x equals the log of 36. Okay. Step 3 is you're going to use property number 5, the power property that says that I can take my power and turn it into a coefficient. So this becomes 2x log base 15 equals log 36. Step 4, your job is to get x by itself. So if I'm multiplying by 2 and multiplying by log 15, how would I move them to the other side? Divide, right? The opposite of multiplication is division. So I'm going to divide by 2, and I'm going to divide by the log of 15. What that does is it leaves my x by itself. But what I do to one side, I have to do to the other. So we have log of 36 divided by 2 log 15. So we moved it to the other side. This is our exact answer. Log 36 divided by 2 log 15 is your exact answer. Step 5 is to evaluate using a calculator. So we're going to get an approximate value using our calculator. As of right now, we're going to use Desmo Scientific because we don't have any handhelds in our classroom. So I'm going to go to Desmo Scientific and I'm going to type in log 36 divided by 2 log 15. And that's what this looks like. So log 36 divided by 2 log 15. Okay, so we have, if we're rounding to the nearest thousandth, it would be 6.662. If we're rounding to the nearest 10,000th, it would be 0.6616. So we're gonna do the 10,000ths to be a little more accurate. The more decimal places you round to, the more accurate you are. So we have 0.6616. And that's our answer. How do we feel about the 5 steps so far? Doable? All right, so we're gonna go through them again on number 2. So again, step 1 is you wanna make sure there's only single terms on both sides, which there are. Check. Step 2 is you're gonna take the log of both sides. So we have the log of 6, 4 to the x equals log 63. After we take the log, we're going to apply property number 5, which is our power property, saying that our power can become a coefficient. So we get 4x log 6 equals log 63. Step 4, we need to get x by itself. So if I'm multiplying by 4, the inverse of that is to divide by 4. If I'm multiplying by log 6, the inverse of that is to divide that. So what I do to one side, I do to the other. So x is now by itself. And we have log 63 divided by 4 log 6. Again, this is my exact answer. So we're going to use our calculator to get our approximate answer. So I'm going to go to the calculator. So control screen. And I'm going to type in, I like to just go ahead and click the fraction. And I'm going to type in log log 63 divided by, what was the bottom one? 4 log 6. I write that correctly. Hit enter. And I get, so this one, if I round to the nearest 10,000th, that 8 is going to turn the 0 into a 1, right? Agreed? Okay. So then we end up with 0.5781. So 0.5781. And that's our approximate value. Still feeling it? What are your questions, comments, or concerns? Now, the beauty about log is that this works even if the bases can be made the same. So let's just say you're not good at breaking down numbers, like 243. You could technically take the log of both sides and then proceed from there. Okay. All right. So this one, we're going to do just a little bit faster. See if we can just kind of shortcut our way through it, right? So this is example number 3. I look and I see that there's no hope. So I'm just going to jump straight into the log. So I have log 5. The power is going to become the exponent equals log 2,115. And I'm going to divide 4 log 5. Cancels that out. Divide 4 log 5. And I'm going to get the approximate value. So steps are to help you build up to this, right? Do you have to go exactly 1, 2, 3, 4, 5 every single time you do it? No, that's for us to learn. So what do we get when we do log 2015 divided by 4 log 5? So log 2015, perfect, divided by 4 log 5, and you said 1.1894, and you are correct. You're a genius. So I'm going to write 1.1894. Okay. So what I want for you to do is I want you to do 1 and 2 in your notebook. We're going to quickly go over them, and then we're going to do 3 and 4 together. Okay. So quickly do 1 and 2, and then we're going to go over them, and then we're going to do 3 and 4 together. But as you finish 1 and 2, before we go over them, I would like to challenge you to try 3 and 4. I've started them already. All right, so let's see what we did. So on the first one, just kind of quickly, you would have n equals log of 49 divided by log of 9. Agreed? And then you plug that in. On the second one, r would equal log of 51 divided by log of 6. Yes? All right, so those two went fairly quickly. Now, on the third one, notice that when it said that step 1 is to make sure that you have one term equal to one term. Well, I had 5 times 18 equals 26/5. So the 18, the power wasn't by itself. So we had to divide by 5. And that's where you end up here. Okay. It was 5 times 18. Yeah. And so that's why it became 26/5. So now you're left with 6x log 18 equals log of 26/5. And you want to leave it as a fraction. So then you divide by 6 log 18 and divide by 6 log 18. And that's what you're putting in. And then you get your X is approximately something. Okay. All right, and then on 4, notice before we did anything, I had to subtract the 3, which left us with 78. Now this one's really important. When you're moving in plus 10, you're moving them together. And because they move together, they're in parentheses. And that left us with log 9 equals log of 78. Oh, yeah. Divide by log 9. Now, how do you move a plus 10? You minus the 10. So that you can know what to do. So that's your exact, and then you put in the calculator to find your approximate. These are what your exacts should have came down to. Okay, 4 would probably be the quote unquote hardest it would get. All right, have a great 4-day weekend. Correction, 3-day weekend. We have school on Monday. Only other schools do not have school on Monday.